DNP3 Basics, Lesson 8, Application Layer, Input Point Object Structure. We are finally down to object details, as shown in our message diagram. This lesson covers detailed contents of each object reporting an input point value. As a reminder, input objects covered by this class include binary input, binary output status, counters running, counters frozen, analog input, and analog output status. Data in each input object contains some or all of three types of information: flags, value, and a timestamp. Information reported is sent in the order shown. Flags are 1 octet, value is 1, 2, or 4 octets, timestamp is 2 or 6 octets. All fields are optional. An object must obviously have one field, but others might be missing because of a variety of reasons. The object variation specifies whether or not an object is reported with flags. The object value or state is normally reported in a 1, 2, or 4 octet field. However, when a binary input object is reported with flags, the state is included in the flag byte. And some binary input point event variations report the time when the event occurred. Let's talk about the fields in the order presented. Flags first. Remember that flags report normal or abnormal status about an input point. Some flags are the same for all objects. Others are unique to an object type. Flag layout is as shown. Flags in the low 5-bit positions are the same for all object types. Flags in the upper 3 positions differ. Here we see flags that are common to all input points. We have the online flag, which is set if the point is online. This is the only flag that is normal when set. The restart flag is set when the value has not been updated since the outstation has restarted. The COM loss flag is set when there is a communication failure between the outstation and the point source, typically used when the outstation is a data concentrator. Remote forced says the value has been overridden somewhere lower than the outstation, typically also used in a data concentrator. And local force says the value has been overridden at the outstation location. Next, we'll talk about the flags that are different for different point types. The first set are for binary inputs, and there's two areas in the flag byte. The first one is CF, the chatter filter. This means the point is chattering or changing state rapidly and still settling into its actual state. Normally, a master would not process a point that was returned with this flag set. It's an indication to wait until next time and then see what the state is. The most significant bit in the flags byte is the state, the current point state, and this is not a flag at all, but is included in the flag object since there is room. Flags for running and frozen counter are two. The first is the rollover flag. This says that the counter has exceeded its maximum count since the prior poll and has restarted counting again from 0. This flag is obsolete, so you cannot be guaranteed that it will be supported in any outstation. The other flag is discontinuity. It means the counter value cannot be compared against the prior reading of the value for this counter to calculate total counts. Normally, this flag is set until the second reading after a device has restarted. The last set of flags are for analogs. The overrange flag means the value is larger than the largest reasonable input or smaller than the smallest possible input for this point. A reference error, the RE flag, says there is a problem with reference inputs associated with this analog. This likely means that the analog value could not be accurately determined and is questionable. Here we have an example of an outstation replying to a request for data with 8 analog points, indices 0 through 7. We can see that analog 0 has a flag value of hex 01, which means the online flag is set. The next analog, analog 1, has a flag value of hex 03, which means the online and restart flags are set. And then hopping down to the fifth analog, we see its flag value is 61 hex, which means the online, overrange, and reference error flags are set. While there are no examples of flags shown for analog output status or binary output status, note, a binary output status point is reported the same way as a static binary input point. The only difference is the object group number. Likewise, an analog output status point is reported the same way as a static analog input point. The only difference is the object group number. And binary output status and analog output status points only include variations with flags. So much for flags. Now we are on to discussing values. Binary first. Binary states are 1 bit. When flags are reported, the state is embedded in the upper bit of the flags byte as shown. When flags are not reported, binary data for 8 points are packed in 1 octet with the lowest index at the right. If the total number of points sent is not an even multiple of 8, the final points are reported in the least significant bits of the final octet, with the most significant bits unused. Values for analog input and analog output status points are signed 2's complement 16 or 32-bit integers. DNP3 also supports floating point values, but those are outside the subsets. Values for counter inputs are 16 or 32-bit integers. For integer values more than 1 octet, the least significant octet is always transmitted first. In these examples, we see a 16-bit counter value transmitted as hex 60 followed by hex 09. 60 is the least significant octet, so the assembled value is a hex 960 or 2400 decimal. Likewise, the 32-bit analog value is 000004 D1 with the least significant octet D1 transmitted first. The decimal value is 1233. We now have two examples of binary data sent in an outstation message. The first example shows two binary events. The object header is 0201, indicating the binary event object group and variation 1 that reports events without time. The qualifier is hex 17 that indicates a count with a 1 octet point index prefix. The range is 2 to report 2 events. The first event has an index prefix of 0 for point 0 and a value of hex 81, indicating the point state is 1 and the online flag is set. The second event has an index prefix of 2 for point 2 and a value of hex 01, indicating the point state is 0 and the online flag is set. The second example reports binary static data. The object header is 0101, indicating the binary static object group and variation 1 that reports packed states. The qualifier is hex 00, indicating start-stop indices followed by range values of 0 and 7 for points 0 through 7. The value for these 8 points is hex 21 or 0010 0001, indicating the states for points 5 and 0 are 1 and the others are 0. Since this variation does not report flags, we can assume that each point is online and that none of the abnormal flags are set. We talked about flags and values. Now a few comments on time. Within the subset levels, the only input object that reports time are binary events. For those, there are two formats, absolute and relative. Absolute time is a 48-bit binary number, 6 octets, that represents the number of milliseconds from midnight, January 1st, 1970. It's used in events to define an exact time when the event occurred. This form is also used in time synchronization messages that will be discussed in a future lesson. Another way to report time is with relative time. Relative time requires two objects. The outstation first sends a time base in its own time object. The time base is the same 6-octet format as an absolute time embedded in the absolute time binary event variation. However, this time object has the additional capability of stating that the time is synchronized or not. An unsynchronized time may or may not be reasonably accurate, but its accuracy within system requirements is questionable. actual system accuracy requirements are defined by the utility and not by DNP3. The relative time binary reports a 16-bit 2-octet time that represents an offset from the time base. The event time is calculated by adding the relative time to the time base. If the clock quality is synchronized, then the same event can be reported using an absolute time or relative time variation. The advantage of relative time is, as a space saver when several events occur within the same minute, or when an event is recorded with a clock of questionable accuracy. Regardless of the time format used, DNP3 requires that all times be sent as UTC. However, it may be possible that some implementations violate this rule and use local time. If important, it is a good idea to check with the device manufacturer. Okay, that's another lesson. What did we learn in this one? First, endpoint objects, part of the subset levels, include binary, counter, and analog inputs, binary output status that provide feedback about binary outputs, and analog output status that provide feedback about analog outputs. Input points may report three types of information: flags, values, and time. All are optional, but we need at least one. Flags are used to report status or quality about an input point. If a point is reported using a variation without flags, then all flags can be implied to be normal. That is, the online flag set and all other flags reset. Binary input events can be reported with time, absolute or relative. The relative time variation can be used to report binary event times, assigning the time a synchronized or unsynchronized quality.